Hello everyone, welcome to my YouTube channel. So in this video we will quickly look at the derivatives of inverse trigonometric functions. So we consider derivatives of inverse functions, and we took some examples which included the derivative of sine inverse. Okay, so in this video we want to look at other trigonometric functions. All right, solution. So the first one says we should find the derivative of cos inverse of x. Okay, so if our y is cos inverse of x, you recall the first thing I said we must do, that is make x the subject of the formula, and if you do that, you have that x is equal to cos y. And so you will need to differentiate x with respect to y. You recall the process we are using here is the process of inverse function. If you get the derivative of x with respect to y, then you will take the reciprocal of it to now get your dy dx. All right, so let's differentiate yx with respect to y. And that is going to give us minus sine y. Okay, so and then when you now take the reciprocal, you are going to have that dy dx will be equal to minus 1 all over sine y. And so this should be our derivative, but we would need to reintroduce our x. And to do that, we will try to find the only thing that has relationship with x here is cos. And so we need to write this sign in terms of cos. And so you recall the relationship I stated earlier, that sine squared y is equal to 1 minus cos squared y. Okay, so that means that sine y alone will be equal to the square root of 1 minus cos y all squared. That's another way of writing this. And so that means if I bring this here now, so it implies that my dy dx is equal to minus 1 all over the square root of 1 minus, then our cos y is equal to x. So, and that's going to give us what? X squared. And this is actually the derivative of cos inverse of x. Okay, so the only difference here is that for sine, there won't be any negative sign here, but for cos, you have the negative sign. Okay, so let's go to example 2, which is tan inverse. So in this case, our y is equal to tan inverse of x, so which implies that our x alone is equal to the tan of y. Okay, and so as usual, we are going to differentiate x with respect to y. And if we do that, we are going to have, remember that the derivative of tan is sec squared. So you have sec squared y. And so this implies that our dy dx is equal to 1 all over sec squared. That's taking the reciprocal. Of course, you know this is over 1. Sec squared y is actually equal to 1 plus the tan squared y. Okay, and why are we using this? Because our tan is directly related to x, and we want to bring back our x into this relation. And so now that is to say that our dy dx is equal to 1 all over sec squared, which is equal to 1 plus tan squared y. Now the tan y alone is x, so that is we are going to have 1 plus x squared, and that is our dy dx for tan inverse of x. Okay, so having seen that of tan inverse, we go to example 3, which is asking us to find that of cot inverse. So in this case, our y is cot inverse of x, and so if y is cot inverse, so it means that x alone is equal to the cot of y. And so if we differentiate x with respect to y, in this case, we are going to have the derivative of cot. You recall, if you check one of our videos, you're going to see that we got it as minus cosec squared. Okay, so we have minus cosec squared y. And so if we now take the reciprocal here. So that means dy dx will now be equal to minus 1 all over cosec squared y. All right. So, but there is a relationship that tells us that our cosec squared, this relationship is coming from cosec squared y minus cot squared y is equal to 1. All right. And all of that, they have their proofs under trigonometric functions. If we now substitute here, our dy dx will now be equal to, why are we bringing cot squared? So that we will be able to substitute for our x. Remember, our x is related to cot, and therefore our dy dx here will be equal to minus 1 all over 1 plus x squared. And that is the derivative of cot inverse of what? Of x. And so, for example 4, the sec of x. All right. So at this point, you remember the next thing to do is to differentiate x with respect to y. And if we differentiate sec with respect to y, we are going to get sec y tan y. All right. And so to get our dy dx, we are going to have that this is equal to 1 all over sec y tan y. Okay, so how do we now substitute our x into what we have here? So already our sec y here is, sorry, this is sec y, not sec x, sorry. So our sec y here is already x, so we can just substitute that here. But what of our tan? So you recall that over here, I said that sec squared y is equal to 1 plus tan squared y. So I can make tan the subject here so that I can then write it in terms of sec. So if I do that, I will get that tan squared y is equal to sec squared y minus 1. That's if this one goes over to this side. And so that means tan y alone will now be equal to, now, but of course, from what we have here, you can see that our sec y, sorry, is equal to x. So I can substitute now. So it means that tan y is equal to the square root of x squared minus 1. All right, so put everything now into this. Therefore, we now have that our dy dx is equal to 1 all over sec y here, we said is x, then multiplied by tan y, which is the whole of this. And so we're multiplying it by the root of x squared minus 1. And that is how we got the derivative of sec inverse of x. And so finally, we are going to look at the cosec inverse. Okay, so recall the first thing to do, we find our x, which is going to be the cosec of y. And so the next is to differentiate x with respect to y. We're going to have the minus cosec y, then cot y. All right. So, and then we'll try to find our dy dx by taking reciprocal, and that is dy dx is equal to minus 1 all over. All right. So now how do we now bring back our x into this function? Because our x is in terms of cosec. So what we want to rewrite here is the cot. So we want to write this cot to be in terms of cosec, because I can simply just substitute here as my x. Then what do I substitute this one with? So I need to write it in terms of cosec. So with this relationship here, I can say that cot squared is equal to cosec squared minus 1. And so if you bring that here, so that means cot y alone is equal to, but our cosec is actually x. So if we substitute here, we are going to have that our cot y is equal to the square root of x squared minus 1. All right, so bring everything now into this equation here. So it then means that our dy dx for cosec inverse of x is actually equal to minus 1 all over our cosec here is x, so we write x here, then square root, which is cot y, square root of our x squared minus 1. And so if you check for cosec and sec, you see that the only difference there is just the presence of the negative sign. And the same thing is applicable for cot and tangent. That's tan inverse and then cot inverse. The only difference is the presence of minus sign. Okay, and this is all we have for this video. That is the derivatives of the inverse trigonometric functions. Kindly subscribe to our YouTube channel and please like, comment, and share our videos and links to your friends that will have need of them. See you in our next video. Bye.